These are the examples of mole-to-mole calculations. The very first thing that I need to do is I need to have a balanced chemical equation. Okay? So I'm looking at this, and it says phosphorus reacts with oxygen to form diphosphorus pentoxide. How many moles of diphosphorus pentoxide will be produced if 1.72 moles of oxygen react with phosphorus? So I need to get my balanced equation first. So as I come up here, I can see that phosphorus is reacting with oxygen. Now remember, oxygen's a super 7. Is phosphorus a super 7? No, it is not. So oxygen and phosphorus are reacting to form diphosphorus pentoxide. Now I have my skeleton equation. I need to balance it. So what I'm going to do is I can see my first problem is going to be I need to have an even amount of oxygens. So I'm going to put that at 10. I'm going to put that at 5 now. And if I put a 4 here, I have balanced my chemical equation, correct? Now I come into the converting from moles of one substance to moles of the other. And we use what we call the molar ratio. Okay, your notes last night told you about the molar ratio, walked you through how to determine it, right? Okay, so I'm going to have 1.72 mole of oxygen. That's what's given. I'm going to do my conversion box. Obviously, what do I want to cancel? Moles of oxygen. So where am I going to put that? On the bottom. Now, I need to know how many moles of oxygen. So where do I get that value from? Where do I get that value from? The coefficient right here, correct? So how many moles of oxygen am I going to put? 5. 5 mole of oxygen. Now, what am I being asked to convert this to? Moles of diphosphorus pentoxide. So what am I going to put on top? Okay, close. You just didn't have a label, Justin. 2 mole P2O5. Now, where did I get that? Coefficient. Now, I go back through like I always do. Do I get to cancel what I want to cancel? Absolutely. So, my label is going to be mole P2O5. Is that what I'm trying to solve for? Yes. So I do my math. I multiply by the top, I divide by the bottom. So I have 1.72, multiply that by 2 to get 3.44, and then I divide that by 5, and I get my value in 3 significant digits to be 0.688. Now, the big part, ladies and gents, the big part is this molar ratio right here. Okay? This step right here, that molar ratio, do you understand how we did it? We read that from the balanced chemical equation. All right? Give me a thumbs up. Vance, you playing today? Okay. Now I'm going to give you a second to write down this second equation. Okay, we have aluminum reacting with oxygen to form aluminum oxide. Aluminum reacts with oxygen to form aluminum oxide. I need to balance my chemical equation. So I have now balanced this equation. My question states, how many moles of aluminum, that's what I'm trying to find, and oxygen. Oops, good thing I read this, because I've got a two-part here. It wants to know how many moles of aluminum and oxygen are needed to produce 7.38 moles of aluminum oxide. So I'm going to start off with my given. 7.38 moles aluminum oxide. Since they asked to get aluminum first, okay, I'm going to go to aluminum first of all. So I have my conversion box. What do I want to cancel? What do I want to cancel? Moles of aluminum oxide. How many moles of aluminum oxide? 2 moles aluminum oxide. And I said I was going to what? I was going to aluminum first. So what am I going to put on the top? 4 moles of aluminum. So when I multiply that together, how many sig figs do I need? 3 sig figs. I am going to get 14.8 moles of aluminum. Because those moles cancel, I'm left with moles of aluminum. Would everybody agree? Now my second part, I'm going to start with the same thing. 7.38 moles of aluminum oxide. This time, I'm going to convert it to oxygen, right? So, in order to cancel, I'm going to have a moles of aluminum oxide on the bottom. On the top, I need 3 moles of oxygen, because I got that from my balanced chemical equation. I get my cancel to occur. So I'm going to take the 7.38 and multiply that by 3, then divide it by 2, and I am going to get, with 3 significant digits, 11.1. My label's going to be moles. Whoa, whoa, whoa. I was going to put moles of aluminum. Is that what I just calculated? Nah. Moles of oxygen.